And of course, there are some freely available content products there. Video streaming. I'm not going to go too much into this. It's being dealt with in another session, I think, by Roger Bolam later on. It may be tomorrow. But these are the main issues, if you like. But what I see as the main issues to do with streaming are mainly to do with copyright and intellectual property rights. I think the technical issues pale into insignificance compared with those. And that's very, very important. And again, we need some sort of authentication to go with it. A bit about directory services. About 8 or 9 months ago, we knocked our heads together over collaboration, and we came up with a process of collaboration. And although it seemed fairly clear and straightforward, in fact, what it boiled down to was that there were two types of directory that you really need. One is a directory of people, because you need to, and that's being piloted by 3 of the RBCs in England. You also need a directory of equipment. And from the point of view of, let's say, telephony, you need a phone book or something online. Or from the point of view of video conferencing, you need a directory of endpoints. And that's what we do need at the moment, because not everybody has a video conferencing endpoint. So if it was a one-to-one relationship, you just find people. And you say, how do you want to collaborate? I've got this, I've got that. But at the moment, not everybody has a video conferencing endpoint. So you have to schedule those separately. And again, we need authentication and authorization. And you'll see this is a theme running right through everything. So video conferencing services, what do schools need? They need booking and scheduling so that they can book a venue or an endpoint. They also need on-demand services for ad hoc sessions so that they don't have to book the sessions. They can just get together at that moment in time, and the service is not guaranteed or not as guaranteed. They need a multi-point service for multi-point video conferences, more than 3 or more endpoints. We provide a dial-out service from our MCU. This gives the RBCs and the local authorities the confidence that they know that everything coming into their region is from us, and that there's nobody coming in from outside. So that actually gives them a very high degree of confidence about where all the video conferencing calls are coming from. It also makes it technically much easier to set up in terms of gatekeeping. And an IP to ISDN gateway service, as I said earlier, it's very important that this is carried on. An ISDN service continues even though we're phasing out ISDN in schools and bringing in IP. And of course, associated with that is who's going to pay the bills, who's going to pay the we have to have a national solution for ISDN billing, which is what we're working on. Perhaps the most important and overlooked side of this is quality assurance assessment. The biggest problems we've had with schools is video conferencing is to do with lack of quality assurance assessment. If they're not quality assured, anything can happen. At least if they've been through some sort of test which has identified the fact that their network is haven't got a part of their equipment switched on, they know about it and they can fix it. But if they don't go through one of these quality assurance assessments, it's very, very difficult, especially for content providers who don't want their time wasted. So we're looking at an automatic QA check, and I'm going to talk about that in a little while if I have time. A bit about the video conferencing services pilot. I started late, so I'll take it a minute or two. The important thing about this was that this was a national project to complement what was going on in the regions. It's very important that we work with the people who are managing the regional networks rather than try and impose anything on them. So this is what we've been doing. It's been a collaborative project. We've been working with all 10 of the RBCs and 4 out of the 11 opt-out LEAs in England, potentially 25,000 schools, but luckily before we started the project, we figured out there were around 2,000 endpoints. So we thought, well, if we get 10% of those in our pilot, that'll be good enough. And the timescales were a year, roughly, up until last month. And piloting during 2 full school terms. The main outcome was that in April 2004, there was a rather uncoordinated situation in the RBCs where they weren't collaborating with one another via video conferencing. I know that's quite a long paragraph there, but you can always read it again later. This is the important bit. By last month, 9 out of the 10 RBCs and all of the opt-out LEAs that were participating were able to intercommunicate using video conferencing via the interconnects to Janet, which means that all over the Janet network. So that's very important from the point of view of the funding bodies. They know that the interconnects are now being used for a bandwidth-intensive application because they provided the money to provide that bandwidth. So bandwidth is, seems to be the topic of the day. So using it is very important as well. Directories. I've already spoken about the 2 directory types. I won't cover that again. And the fact that most of the problems with video conferencing have been to do with quality assurance assessment. And all video conferencing calls are on a dial-out basis, which gives the RBCs and LEAs confidence and trust in what's coming in. We had about 350 conferences. We had about 250. And we're now anticipating thousands of schools being registered over the next few months. And about 50% of the calls were actually for teaching. They weren't just playing about. These were scheduled classes. So we were very pleased about this, that it wasn't just a pilot of, hello, how are you, and all this sort of stuff. It was actually real sessions delivering real teaching. And 50% of the calls used the IP to ISDN gateway. So there's still quite a large demand for ISDN connectivity. And the bandwidth was generally for the IP and ISDN, obviously 384, and for IP to IP was mostly 768. We did some interoperability tests with MCUs, and these proved quite successful. So we've got some standards-based MCUs on the Janet network that are communicating with, for instance, click-to-meet servers in London and elsewhere. And we're planning more interoperability tests. This is quite an important area to overcome because the regions, quite a few of them, have gone out and bought their own equipment, and they expect to use that equipment for internal video conferences and want to use us for external, national and international video conferencing. I've already mentioned the billing solution, and next month, I'm not sure if Roger is going to say a bit more about this tomorrow, but UKERNA is launching a JVCS on-demand and a JVCS check service. This will enable the booking, or not the booking, but the scheduling of video conferences for immediate consumption so that you can book up to 48 hours ahead. But it also means that you can just say, I want a video conference now with that person, and that person, and that's it. But you have extra facilities so that you can control. The chair can control, for instance, the mute or unmute at each of the endpoints, this sort of thing. So it's quite a sophisticated system. A bit about content providers. In March, we announced that we were bringing on board all of the content providers that provided national content. We see this as a very important step to encourage schools to take up video conferencing. If the content isn't there, why should they do it? They can keep talking to one another, or they can keep saying hello, but what they really want is some solid content. And so we extended the Janet video conferencing service to all national content providers and regional content providers that provide national content. And I think that's a very important step forward. IP connectivity is a major issue for content providers, and we're working closely with them to resolve this. And we've recently agreed to fund the National Archives in Kew, or part fund in a collaborative project, and also the National Space Centre in Coventry. So a bit about support. Apart from regional support centres, which may have already been in place, the national support is for the regions. The national support can't filter down into the schools themselves directly. It would not scale if you tried to do that, certainly with the numbers of schools we're talking about. So what we're looking at is support directly for the regions and for the local authorities so that they can cascade the support down to the schools. We've got a number of operations staff on the Janet video conferencing service, and they help with problems at the start of video conferences, and that's quite important to have a bit of hand-holding at that particular moment in time. If something goes wrong, if they have the wrong number or just anything can happen, and so it's very important that hand-holding is there. And they also undertake the quality assurance assessments. We also got a video technology advisory service. It's about 8 experts across the country who visit places on a consultancy basis very often, but they were involved in this project, and they visited every region and every local authority that was involved and discussed their problems with them, especially to do with the deployment and configuration of gatekeepers. Now, I haven't gone into any technical issues about gatekeepers here, but that has been the main crux of the technical deployment. It's putting in an H323 gatekeeper proxy into each region or local authority. And getting that right, getting all of the support right, has been the key to the success, because it's been that support, that national support, has been very, very popular with the regions, and they've responded very positively about that. A little bit about the gateway to the health sector. We've been dealing with some children's hospital schools in London, and also medical school in Cardiff. And they've got different needs, but the outcome is probably going to be the same, is that we're going to have to set up some sort of gateway between the Janet MCU and the health service MCU. And the important thing about video conferencing there is that it can deliver interactive content to a child that's stuck in a hospital and can't be moved. The education still has to be delivered to people, despite the fact they're not in a normal school environment. So the JISC has selected Shibboleth for higher and further education. HCs have selected Shibboleth for schools. Scotland and Northern Ireland are going down the same route as well. And there are a couple of pilots that are just coming to conclusion at the moment. In London, they're quite a long way down the route of implementing Shibboleth. And I think I would not be surprised if they would be prepared to announce that they had actually rolled it out as a single sign-on solution. Current issues are multiple federations. Should we have one for higher and further education and one for schools, or should they be the same? Certificates, who authorises the certificates, edu-person attributes, and also there's apparently a date of birth discussion going on at the moment as to exactly what format that should be in. And Shibboleth is being implemented in the Janet video conferencing service so that it ties in with all of the other content services that are going on. So, this is my penultimate slide. If you're interested in any international video conferencing collaboration, either get hold of myself or Tommy Dolenk. I think, is Tommy here now? Yeah, up the back there. Hi, Tommy. And also, Roger Blameyer of the European SchoolNet will be very interested in talking to people about extending collaboration internationally. So, a bit of further information here. The second of those links is to the standards documents. They're not really standards documents, they're guidance documents, as we prefer to call them, that we did for the DFES a year or so ago. And they contain quite a lot of detailed information, and also the information about the video conferencing pilot for schools. For those of you who want a bit more information about that, I've got some leaflets here. I'll also have these at the BOF session tomorrow. So if you want to pick up one of these on the video conferencing pilot, please come and get one. I think that's it. Do widzenia.
Thank you very much, Rob. We've got time for one question.
Hi.
Can you just wait for the microphone because it helps with the streaming?
It's more a comment more than a question. I'm Eric Sang from Canada.
Hi.
And one of the things we have found working with school for the last number of years, at least 5 years, to demonstrate what the value proposition of broadband will bring to the school. It's not only that faster speed to access the web or receiving information. What we look at it is that using broadband, how the teacher and student themselves become content providers. We are looking at how schools can use the broadband, especially for collaborative environment. how they can actually work together and solve problems, no different than what Ed talked about just an hour ago. But we have come down to the school level, how they actually can work together. Give you examples that they actually compose music together virtually across Canada. They play music together. They solve problems. Some of them are, for example, water as a scarce resources, cultural diversity. In Canada, we have that issue that we deal with similar to other countries. So actually, how we actually in different part of Canada can use the broadband to bring value and reach out to the student themselves rather than just a recipient of information. So it's if people talk about broadband to school, think about the kids themselves are pretty smart. They produce content too. Thank you.
Thanks. Yeah, that did come up in one of our meetings with content providers. One of them said, well, the kids can deliver the content. And yeah, there's no reason why not.
Actually, the kids themselves operate all the equipment. Right now, the school is operating all the broadband equipment and collaborative equipment without even us knowing it. They're actually doing it all the time. It's sustainable, pervasive, and persistent.
Good. Yeah. Well, perhaps we can collaborate with you. Yeah, good.
It sounds as though you should go to the BOF tomorrow afternoon with Rob to talk about schools.
Yeah.
Okay.
Thank you.
Okay, our next speaker is Alessandro Yoshi Poliotti, who comes from Italy, and he's going to talk about a system designed to create a network for scientific document sharing. So he's coming at it from the research angle. So I'll hand straight over to Alessandro once he gets mic'd up.
Okay. Is it okay? So today I'm here to talk about a software product we are developing. Currently, is it still in a project state? Our concern is about knowledge exchange, because we think that currently knowledge exchange suffers from a number of problems. The main being that a lot of the producers, so researchers don't receive an acceptable amount of what is currently being produced. That about 90% it is lost mainly at an early stage when it goes to publishers from the researchers. We see that immediately we have a drop in the number of papers that are being disseminated around in the network of research. The peer review process doesn't put a big stop to the number of documents which are submitted in the first place. The second bottleneck in this circuit of publishing happens when libraries have to buy the papers in the form of journals, because journals are many, they are always new journals, and they cost a lot of money, which not always libraries have to spend. So they have to build consortiums, and so the number of subscriptions is lowering, and the cost of a single subscription is going high. A first response to this kind of problem is the Archives Initiative, which is an initiative made for open access of papers. We see the problem mainly here is that open archives are not widely known. So we have a big return, which is almost 100%, but we have a low quantity of papers that is uploaded to these archives. Open archives are based on 3 layers of software. Data providers are software that allow the other levels to interoperate with heterogeneous software that is databases or any kind of archive. And they provide abstraction by means of the OAI PMH protocol, which is XML over HTTP. Harvesters collect metadata from the different providers and give it to service providers, which in fact build services on top of metadata collections. Service providers are, for example, search engines. So, what does happen here? First, we have a number of search engines which harvest different content providers. We have different kind of services, of quality of services. We don't know which service providers hold which data providers' data, and so on. Further, since it's still a voluntary effort, the Open Archives Initiative software is usually quite hard to install, and so requires an engineer. The Biblioteca di Alessandria, which is a reference to the Library of Alexandria in Egypt, is a project that aims to solve some of the problems that we have found in Open Archives. We have the same objectives, more or less, but we want everything to be as simple as possible for the end user, because we think in the end it's the end user experience that makes a system good or bad. So we want to provide researchers and research institutions with a tool that gives them a chance to be content providers themselves, no matter if they are small or big, and that allows them to accelerate their own work in every day. So you have an instrument not only for archiving purposes, but also for searching purposes and so on. Our end users have 2 kinds of software before them. We have one called Free Science, which is tuned for single users, and allows them to build simple digital archives. They are unstructured archives. The software allows them to share, search, and download their own content or the content provided by other researchers. They may communicate via instant messaging like ICQ or MSN Messenger. And so this is what a single person may use our software for. Archive Maker, on the other hand, is made for larger institutions. This way, this time we focus on structure. So what is small and simple on a user level becomes large and cumbersome on an institution level. Institutions have departments. They want to split their archives and give them structure and make them easy to search and to share. So users may organize them in groups. Groups may choose other groups as the sharing peers. So we may choose our documents to be visible only inside our group, to be visible to some groups or to everyone. It is possible to build web pages which are usually compiled by hand and which have a full list of all the documents that our researchers are currently sharing, what they have put into the system. So no need to receive, for example, an email from the researcher which will state that I have published this paper on this journal, these are the bibliographic informations, etc. Everything is automatic. Also, it is possible to be an Open Archives data provider with a click. So, any time we can choose our entire document collection to be available through Open Archives, which is an opportunity to reach some more people, which is currently not using Biblioteca Alessandra. A quick look at our architecture. We have a peer-to-peer network of clients. As we will see, they handle automatically the file transfers. We have at the base of our system MySQL, database management system. We have the JBoss application server, and on top of that we have Tomcat running and some enterprise Java beans. We have an OAI data provider module. We have web publishing module, an indexer which is also responsible for searching, for allowing other people to find documents in the system, and a client interface, which is the way clients interact with the system and with each other. Here are listed also OAI data providers and service providers which are not part of the system which interact with us. As I said, our clients use our server to search and share documents. However, downloads happen directly between the client nodes. This gives us a higher bandwidth possible, replication, high availability, and so on. We export our metadata, the information regarding our documents. We import metadata from other archives, so searches take place both on internal documents and external documents. And finally, clients may download, if possible, because not all Open Archives give the ability to download full text. It may, if this is possible, it is possible through a simple web browser. Our peer-to-peer file sharing, as I said, is based on metadata. Metadata is the bibliographic information of a paper published. Anyway, it is recognizable and searchable through its information like keywords, abstract, and so on. Each metadata is time-stamped, so possible to know if a certain work was inserted before another for any kind of legal issue or problems. It has versioning support and collection support are being worked on. So it is possible, for example, to insert chapters of a book and then group them in the whole book. And it is possible to have different versions of a document. This is important. Our system doesn't use file names to recognize files, but rather it works on its content with a hash code. So it is for those maybe who don't know what a hash code is, it is a number calculated on the content of a file. Simply this. And it is unique or quite hard to find a collision on this number. Peer-to-peer file sharing, as I said, is based on metadata, so users will find that they will want to download it. They will select like a BitTorrent client tracker or a Donkey 2000 server. In that, it will put into all content providers, let's say, all nodes that own a copy of the file with the nodes that need a copy of the file, and they will arrange for file transfers on their own without any further interaction with the server. Currently, the download proceeds sequentially. In a few days, it will be possible to have random blocks of the file being downloaded. So it is easier to have a full copy of the file in the network, even if no one has one full copy in his system. A quick note about firewalls, since it's one of the frequently asked questions about our system. We have three types of nodes, of clients. Nodes that have full access to the network, they have a public IP. B nodes that have only limited access, but they may open any kind of connection as long as it is outbound. And C nodes that maybe are behind a very powerful firewall. They may open maybe only a connection on some ports like HTTP, HTTPS, and so on. C nodes may not connect at all to the service unless the necessary ports are being opened, which are 1089, 1090, which are the JBoss default ports currently. B nodes may connect to the service, but they may not exchange directly between them their files. And A nodes may be able to connect and share files with anyone, as long as that one is able to open a connection. So we are studying heuristics to solve the problem of B nodes, because sometimes we have rather large networks that are behind a single firewall. So it is possible to get a route between two B nodes if they are behind the same firewall. If we detect this kind of situation, we may allow them to connect with their internal IPs. Other than this, we are preparing a software, a small software that may be used to store automatically or the data that is being shared by an organization. This software is or a specially arranged node. It may be possible for it to grant high availability and the replication for all the data. It may be even a backup server for the organization. Our search engine has been built from scratch. We support search on metadata fields. Some fields even allow users to insert Boolean queries expressed with the usual language of queries, with wildcards, sentences, and Boolean operators. Our index is permanent. Many peer-to-peer softwares don't have a permanent index because of what happened to Napster, essentially. Because Napster was considered responsible for what was being exchanged on its network because of the index. However, we are exchanging material that is not the type of copyright infringing material that was on Napster. So we are confident that this is the best choice. because we have a larger database. It is possible every time a user comes up on the network to share automatically the same files, and they are automatically recognized and shared with anyone on the network. Our system, as I said, supports groups, user groups. Users may belong to one or more groups and may publish their documents in any one of their groups. Groups are organized in a hierarchy, in a tree, usual tree relationships. And other than that, as I said before, we have sharing relationships among them, which do not have to follow strictly the tree hierarchy, but maybe have any kind. We may have any kind of relationships between very different groups, because, for example, we are collaborating with someone who is in another institutions, in another place. We need to share files with them, our working papers, our results, etc. Some users are bound to have administrative tasks, of course. So we have three classes of them. We have normal users who may upload their files. Upload is not the right word. However, they may submit new files. They may also change metadata about their files. For example, updating them. I've written today a paper. In 8 months, it becomes published on a journal. I may update the state of my paper. We have editors who work on a metadata level. They have the final word on what is visible outside their group under their supervision. They also are able to edit any metadata in their group because they may want to apply certain policies regarding their format or their completeness. Finally, we have administrators which work at a higher level. They handle memberships, they handle groups themselves, they create new groups, they change permissions, they build sharing relationships. So they work at a different level from other users. It is possible to see metadata from the web. It is not possible currently. Maybe in the future it will be to download files directly from the web because of the nature of our system. It shows the hierarchy of groups. It is possible to browse the hierarchy to see what a certain group contains. So it is possible to have the full bibliography, for example, of an institution. So it is possible to show that an institution is producing knowledge. This will, it is likely to that this will attract more collaborations. It will be possible searching by Google our topic of interest to find other people who is working on something. So it will be generally easier to set up collaboration between researchers. We can host it on our server, or we can allow others to display this window looking on their metadata on their own server, because we export the data in XML format, and it is possible to later work on it with style sheets. Well, I finished. I hope you enjoyed the presentation and are more interested in the system I just talked about.
Thank you very much. Have we got any questions? We've got some time. There's one right at the back. Can you wait for the microphone, please?
Yes. How do you do peer review of the documents that are published?
Currently, we are studying this issue because we are still at an earlier stage of technology development. So we have a beta version which is working, but doesn't have all the features I have said right now. We are still working mainly on this issue. However, we have some, we think, good ideas about peer review. We don't want to be to superimpose us on the publisher's work, because this would be very hard in the beginning. As soon as we have a critical mass of papers, we may be able to offer some kind of peer review process inside the community. But first we need users and we need papers. So when the community has been built, we will have, I think, good chances to build a new system for peer review based on the community.
Any more questions? No? Thank you very much, Alessandra.
Okay.
Our next speaker is Joseph Harden. He's the director of the Collaborative Technologies Laboratory in the Derndestad Center and a clinical assistant professor in the School of Information at the University of Michigan. But he's also the chairman of the board for the Sakai project. And that's what he's going to talk to us about this afternoon. So welcome to Joseph.
Thank you very much. I'm going to put the slides up instead of my talking head, and people can, somebody there is going to be moving through the slides on the big screen. Is that right? So people can read them?
Yes, that's correct.
Okay, doke. Let me get these up on the screen. And I will in just a second. There. So you should be seeing the slides now. Is that right?
Yes.
Okay, doke. I'm going to give an overview of the Sakai project, talk a little bit about where we got started, or how we got started, and a little bit of the organization, the software, and where we're headed. So this is an overview. The idea here is that we're interested in building open source educational and research infrastructure. That includes course management systems and also research collaboration tools. We're interested in more than just a course management system. We're interested in a form of groupware that allows people to carry on research activities in distributed teams. This is what these types of software, these types of systems are now key infrastructure at our universities. Over the last 4 years, 3 or 4 years, it's become not just a good idea to have these, but rather a requirement. A huge number of our faculty and students and staff, both teaching, research, and administrative, all use these kinds of systems, and so it's a requirement. We need to keep this kind of software up 24/7, 365. Excuse me. And we need to make sure, as this keeps growing, that we can scale up. So the challenges for higher education that we see in this area are being able to bring innovation into these systems rapidly, innovation that comes from our faculty, both teaching and research, and from our students, and doing this in an economic manner, doing this in a way that the economies of scale are realized and that our educational institutions can keep up with it. So we're talking about software that supports class activities. This is support for online support for traditional class activities. These are the tools. I'm sure that everybody's aware of these, is familiar with these, so I'm going to just show a couple slides. This one has a schedule, a resources area, a place to put information about the people in the class. These tools allow you to build assignments, keep email archives, have discussion groups, do chat. These are the kinds of things that people do in support of traditional classrooms, and also these are the same kinds of tools that people use in distance learning. And the Sakai software has been used for both. It's also used, as I said, for supporting lab activities, supporting scientific research teams that are distributed, both in communications among the individuals and in using remote facilities. And this is an example of Sakai as what we call collaboratories here in the States, support for online research teams. So those are the kinds of things that we're shooting for. Those are the kinds of tools that we've built in the past, and the goal with Sakai is to combine them in one set of tools so that if a faculty member is familiar with using them in the research lab, they can easily use them in their teaching and vice versa, so that you can push adoption from both sides. So the project was started around 2004, January the 1st, and Michigan, Indiana, MIT, Stanford, the uPortal Consortium, and the Open Knowledge Initiative decided to get together, and instead of building their own next generation systems or adopting other systems which they would not have as much control over or were not necessarily open source systems, they decided to work together. Each of these schools had built in the past a course management system and some of the research support tools that we've seen here for their own school. At MIT it was Stellar, at Stanford it was Coursework, at Indiana it was called OnCourse, and at Michigan it was Course Tools. The idea is to get together and work on this together. We got some funding, but initially the important thing is that there's a heavy commitment from these founding schools. We're going to make sure that this works, that the first generation of this gets out, and we're going to use it at our own schools. Why are we doing this? All the simple reasons that I've mentioned, economic reasons. It matches up with our higher ed values. Doing an open source system like this, sharing, building the commons, this is naturally resonates with the way we do business in universities. And we need core support for collaboration technology as the university expands out beyond the bricks and mortar. And again, we need the ability to rapidly innovate. There's lots of activity going on that our faculty are the first to figure out, even more activity that our students are the first to figure out, and we need to be able to bring that into the system quickly. So if an interesting tool is built at Michigan, or if an interesting method is developed at Indiana, MIT can pull it into their system and start using it with their students and faculty right away. Our timeline was fairly aggressive. We were going to have our 2.0 out, that it would have the new architecture with the modularity in it that we wanted, and the kernel built in the way that we wanted it. We're in final QA now, and there'll be a release around the 15th. So we're pretty much on track. There have been some bumps in the road, but it's going okay. The deliverables were indeed the working code itself, a tool portability profile, which is a spec, which allows people to build tools. And basically this is what you give to developers and say, if you build to this, it's going to drop into the system, and it's going to work with the other services and tools in the system. And of course, throughout this, the 4 schools committed to adopting the software as their course management system and to help build the community as they went along. So that's the basic strategy is pretty simple. Partner with schools that are like us and build a community, build the open source community around a modular open source framework. So Sakai is a project. It's a 2-year project funded by Mellon, which is our startup. This is to get the seed software out there in the first generation. It's a framework that you can build to. It's a set of tools that are built to that framework and can be integrated. It's a released bundle, a product, which is 2 of those things combined, tools and framework, that you can take out of the box and start up and use as a course management or research support or groupware support tool. And it's a community of people that are interested in building these and are revving the software. The technical goals were to provide an environment for tool portability, and part of that included modularization so that new tools would not destabilize the existing tools, make it easy to port, and also to allow tools to exist and as standalone. This was a requirement that came both from faculty who were teaching and doing research because they wanted the richer user interfaces that were available in, say, an application and not something that was forced to come through the browser. The tools, as they're released, are all available through the browser, but if somebody wants to build a tool or build an additional user interface and with added capability, they certainly can as an application. And of course, we're working with web services, so services and tools can be accessed easily. The foundational documents include a style guide, a Java framework description, and a tool portability profile, which I mentioned earlier. All these things are available if you start out at the sakaiproject.org website. We're using a service-oriented architecture to decompose tool into presentation and service elements. People who are familiar with these type of architectures can see that this is pretty straightforward application of one. Let's see. The Sakai application framework is the kernel and a set of common services and presentation services. I'm not going to go into much detail here. This is a Java system, uses JSF. You can use other presentation frameworks, but that's the one that we're building a set of tags for, and it works completely with the system. The common services include authentication, authorization, hierarchy, repository, the normal suspects, the normal set of things that you would want there, and it's being revved as we go along. So if you want to integrate something or you want to build a tool for Sakai, you can build a totally compliant tool using all these. You can integrate a web application, in which case you might be responsible for your own presentation. You can just build something and stick it in an iframe and decide which points in the services, whether it's authentication, authorization, that you're going to tie into, or you can use all of them, or you can integrate via web services. And that's We've got a system that's more than a CMS. It's a collaboration and learning environment. It's used, as I said, for teaching and learning, online research communities with faculty, research staff, and students, and support for our staff, project work and surveys, for instance. All this is made easier by the ability of any user to set up a group workspace. So it's not just faculty that can set up classes. Researchers can set up project teams. Students can set up groups to do projects in their classes or with other students or with students scattered around the country or the world. Certainly Sakai is in production now at the University of Michigan and Indiana. We've got over 25,000 users last semester in the local branded version of Sakai, which we call C-Tools. It's the Sakai software. We've just put this was with over 1,000 course sites and 2,000 selections, so we spent a lot of time working on performance. And our transition from our legacy system of course tools is going to be done. We're now moving the last people over this summer, and this fall of 2005 we will come up as an all Sakai C-Tool system. We'll have about 40,000 users. There'll be 2,000 or 3,000 faculty that are using it, and it'll be our production system for the whole school. So that's the background. I'll talk a little bit about the community. We've been in the process of building an organization called the Sakai Educational Partners Program, which is all higher education based, and in building something we call the Sakai Commercial Affiliates, which is just what it sounds like. It's commercial organizations that are interested in supporting the software and providing services to Sakai users. That way, if universities or companies, whoever, want to use the software, they have choices. They can install it, run it themselves, as we do at Michigan, or they can find an ASP or somebody who could come in on a consulting basis and provide sufficient services to get them up. Also, we're working with IMS specifically on standards of interoperability between course management systems and systems like this, so that people can build tools that will eventually work across all the systems. And the demonstration tool for this that will be tested out in a few weeks and demonstrated is a testing and assessment tool called Samigo, which is currently working in Sakai. The Partners Program is $10,000 a year, $5,000 for smaller schools, and you commit for 3 years. For this, you get a little better access to SEP staff. Remember, this is an open source project, so anybody can go in and get the code. Anybody can email Sakai dev or Sakai user and ask questions and contribute to the project. But there are staff that can work with your developers if you're a SEP partner, and you get invitations to the partners conferences, which so far have happened twice a year. But most importantly, you get to be part of the conversation. You get a seat at the table as Sakai develops, as we figure out how to do this and how we should go in the future. So the success of the whole SEP effort really will determine the success of the project as a whole. The code is one thing, but it's only the community that can support the code. Current partners, there's around 70, 75 of them. They're scattered around the US, Europe, and Asia, some in South Africa, Japan. I think we've got a number of people. We've got people from 5 continents coming to the conference. It's coming up this week, actually. There's a bunch of people that we know are putting the software into pilot and production. We find out about this through press releases a lot of times. People just go ahead and pull down the code and then start it up. And then when somebody does a survey of user satisfaction, it makes the student newspaper and we find out about it. A lot of these people, of course, we're working with much more closely, but you can see that there's quite a few different places that are committed to putting it up this fall. So one of the things that's important, of course, in a system like this, in a project like this, is that you get contributions back from your partners, and this is a quick look at a couple examples of that. A Gradebook is coming in from Berkeley, which allows people to record grades and is integrated with the assignment tool and with the testing tool. It's been part of the 1.5 release, but is more fully integrated in the 2.0. There's a set of tools that help graduate students walk through the process of working on their dissertation and coordinating with their chair of their committee, their school, and the graduate college. Basically, it's keeping track of student progress toward a degree. I mentioned an assessment tool that's coming from Stanford that helps people build surveys or questionnaires, multiple choice questions. This was originally built for use with foreign language classes, and so has fairly good audio support for both setting up tests where the question is asked in audio, or for taking answers in audio and allowing those to be graded. There's also a tool that's come from Foothill College called Mileti, which is an online lesson authoring tool. This is part of a much larger project in California with 48 community colleges. They're currently in pilot with 300 faculty from 17 community and all 48 colleges are going to integrate by July 1st, 2007. Sakai, to look very differently, indeed have skinned it down to the site level. Sakai allows for that. And they've built a lesson builder. And this is which allows people to build lessons, and then the students can step through them online. I won't go into the details. Again, this is something you can look at when you pull down the 2.0 version and the Mileti add-on. You can do composition, uploading a course, linking. It has support for accessibility for alternative representations, video and audio, and the student view is pretty straightforward. You have modules and the student steps through them, and like I said, it's integrated with different elements. It also has strong support for Creative Commons copyright types, which is something that we're encouraging here. There is the Open Source Portfolio Initiative, Auspey, which is tracking our development, and about 2 or 3 weeks after we do a release, their portfolio tool comes into the release. So all these are examples of distributed development, and gives us some hope that this is something that more and more people will pick up on. So The contribution community, as I said earlier, is not only these partners, it's everybody who's contributed a bug fix, and some people who are working on integrating relatively larger tools like wikis, blogs, Jabber, SCORM players, and RDF-based tools. So this is a rapidly growing area, and of course one of the things that we're encouraging strongly. The commercial affiliates, there was a first generation of small organizations, and this is some of them, and recently there's been a number of large organizations that have said they want to act as ASPs. IBM is one of those. They bring the kind of thing, including code donations and work with reference architecture that they have to projects like Linux and Apache. And recently, in fact, there's a press release that comes out today that says Sun and Unisys are joining the Sakai commercial affiliates. We think this is, of course, a validation of the open source model. We consider these people useful partners in the open source community, but the real community, of course, is the people in higher education that are building the tools that I mentioned earlier. So we see these open source projects as crucial to supporting innovation in higher ed, and there's a literature developing around these dynamics that we're helping to contribute to. I'd encourage everybody to take a look at Stephen Weber's book, by the way. The Sakai project is a bit of a pioneer in some of this, and it's devising its own open source strategy, which we call community source, where there is a group, a consortium at the center of the development, and open source methods in the licensing and development that are used throughout the project. We're in the process of doing this, so we don't know exactly what it's going to look like. This is part of a much larger whole as we see other projects that are doing the same thing, from repository projects to projects like uPortal or Auspey that I've mentioned before. There's a number of them. We're all getting together this week in Baltimore, starting, day after tomorrow, I think. And the materials for all of this, like I said, and for contributing, looking at the software, helping with bugs, looking at the collaboration tools, or working with the partners, you can start out at sakaiproject.org, hit the Sakai dev or user lists, and see what's going on there. Our conference, as I said, is coming up, and there'll be about 400 attendees from about 14 countries. So that's it. The last thing, every once in a while people ask us about the name, and it helps to explain that there was a previous project that was called the Chef Project. I don't know how many people in the audience know the Japanese Iron Chef TV show. This is a campy, fun, kind of goofy cooking show that has people on it who come in and compete in the kitchen. We liked the show, and so we called some of the early software here at Michigan Chef. Sakai is one of the chefs on the show, and at one time we took his name and built an acronym, but the acronym was too big a mouthful, it's just too many words. So now we just call it Sakai. It's the name of a famous Iron Chef, so it's just fun. And there's also a character that goes along with it that talks about moving across boundaries, which we hope is appropriate for us. So that's my presentation. If there's any questions, I could take them now.
Thank you very much, Joseph. That was a very interesting presentation. Have we got any questions? Because this is your only opportunity to ask. We're just waiting for the microphone to go to the questioner.
Yeah, I'll play with the camera while that's going on.
Hi, Brian Gilmore from Edinburgh University. Is it working? Can I just ask you to underline the extent to which you're committed to moving the project outside your kind of current institutions, and the extent to which you do wish to see this being taken up kind of worldwide?
Yeah, sure. That's the whole point of the SEP Partners Program. And that's part of the discussion that's going on here in Baltimore at the conference. basically what we're going to do is the current board, which is made up of people from the 4 schools, the initial schools, and partners that we've brought on from, let's see, University of California, Berkeley, Foothill College, University of Hull in England, and the University of Toronto. We're going to go through a process where we become, and we're not exactly sure what the process is yet, but we're all going to become the board for, or go through an election or something, where now we're not just representatives of the project, but representatives of all the SEP partners. At the same time, I mean, so organizationally, we're moving away from the 4 core schools as fast as we can. That'll be completed by the end of the year when the project, the Mellon-funded part of the project ends. In addition, we're working on internationalization, localization efforts, and I just did for instance, there was just a Sakai Day in Switzerland and Germany, where at each respective site there were about 100 people. I just did a swing through Japan where I hit 3 schools in Tokyo, Nagoya, and Kumamoto, where there were about 50 or 100 people at each of those presentations. And those people are starting to contribute and work with the software. So we're working as hard as we can to make sure that this quickly moves out from under the purview. Does that help answer the question?
Yes, thank you very much.
Any further questions? Okay, I'd like to say thank you very much to Joseph, but also to all our speakers this afternoon. Thank you very much. The coaches go back to the hotels